Hello class, welcome to Chemistry Lecture 7-1. This is Mr. Worley, and I'm glad you're here. I want to point out first our objectives for this chapter are to explain the significance of a chemical formula, determine the formula of an ionic compound formed between two given ions, name an ionic compound given its formula. We want to, using prefixes, name a binary molecular compound from its formula. And we want to write the formula of a binary ionic compound given its name. This is a big section. It's got a lot to learn, and so it's going to take you a while, but it's really important. Today our lecture exercises are page 231, numbers 1 through 5, and we're doing problem solving follow along, which means during our lecture I'd like you to follow along with 2 or 3 problems that I do with the lecture so you can kind of get what we're doing. Okay, before we start, make sure that you have your book opened up to page 219 right here. You need your book, 219. You also need to have a pen and paper handy. I have gone ahead and labeled my paper like I'd like you to label it. Your name here, class, and I want you to say Chapter 7, Learning 7-1, Learning Notes. L.E represents learning lecture exercises, page 231, numbers 1 through 5. I recommend going ahead with the Cornell style of note-taking. You can take any style you want. Other things you might want to have handy are a couple of markers, different colors, as well as a ruler to make nice straight lines if you want, and a pencil. All right, make sure you have a good study environment because here we go. Please open your book to page 219 at this time. And let's read along together. The total number of natural and synthetic chemical compounds run in the millions. For some of these substances, certain common names remain in everyday use. For example, calcium carbonate is better known as limestone, and sodium chloride is usually referred to simply as table salt. As everyone recognizes, dihydrogen monoxide is by the popular name water. What does that mean? Dihydrogen, that's H2, monoxide means O, water. Very cool. Unfortunately, common names usually give no information about chemical composition. To describe the atomic makeup of compounds, chemists use a systematic method of naming compounds and to writing formulas. In this chapter, you will be introduced to some of the rules used to identify simple chemical compounds. All right. So, significance of a chemical compound. A good place to maybe write in your notes, section 1, maybe significance of chemical formulas. All right. Recall that the chemical formula indicates the relative number of atoms of each kind of a chemical compound. For a molecular compound, the chemical formula reveals the number of atoms of each element contained in a single molecule of the compound, as shown below for hydrogen, as for the hydrocarbon octane. Hydrocarbons are molecular compounds composed of solely carbon and hydrogen. Okay, so basically what this means is that there are 8 carbons and 18 hydrogens in this molecule. That's what these letters represent. That sounds like a good quiz question. What do the subscripts represent? Unlike a molecular compound, an ionic compound consists of a lattice of positive and negative ions held together by mutual attraction. The chemical formula for an ionic compound represents one formula unit, the simplest ratio of the compound's positive ions, cations, and its negative ions, anions. The chemical formula for aluminum sulfate, an ionic compound consisting of aluminum cations and polyatomic sulfate ions, is written as shown on the next page. All right, let's go to the next page. So I'm on the next page, and here we go. This is an ionic compound. What does that mean? That means no electrons are being shared. It's just positive and negative ions. So it says the subscript 2 refers to 2 aluminum ions. The subscript 4 refers to 4 oxygen atoms in sulfate and in sulfate ion. And subscript 3 refers to everything inside the parentheses, giving 3 sulfate ion, which with a total of 3 sulfur atoms and 12 oxygen atoms. I've got a little visual concept for you guys. Let's check this out on the computer. Right here. All right. right, so here's basically our two examples. The C represents carbon, 8 represents the number of carbon atoms, 8 represents hydrogen, 18 is the number of hydrogen atoms. Okay, so far so good. Aluminum, well that represents aluminum. The 2 represents that there's 2 alumina atoms in the molecule. Sulfur, that's the S. Oxygen, that's the O. 4 oxygens in this molecule. And the parentheses say that SO4 is actually one ion, a polyatomic ion. And in this molecule there are 3 SO4s, or 3 sulfate ions. Okay, so that's what that means. Let's go back to our book. Reading right along with monoatomic ions. Please go to the next video.